You can also see that this thermo part is for thermal, that is heat, and dynamic, that means motion. So basically, we need to study what if when we are going to study the motion of the heat, that comes under thermodynamics. And in this chapter, there are some important terms that we need to study, and that is the first term that we are going to discuss is your system. So what is system? What is system? So it's very easy. Any process that you are carrying in any container or at any place, that container or the place is called system. If you are making tea, so the container in which you are making or preparing the tea is called system. Or if you are boiling or water, or if you are carrying any chemical or physical process in any container or in anything, that substance or that area or basically that container is known as system. Now, what is surrounding? Now, what is surrounding? Just uh, after the system, let's say this is your system in which you are carrying the reaction. So if this will be your system, then just after this is your boundary of the system. This is the boundary of the system. You can see just after this boundary, this will be your surrounding. This will be your surrounding. There is another term in this chapter, that is your universe. That is your universe. And what is universe? So basically, if you are going to add this system plus surrounding, then that will be your universe. So it's very easy. Let's take an example. If you are boiling milk, then that container in which you are boiling the milk is your system. And just after the system, that will be your surrounding you can take. And in the kitchen, you can take the kitchen and the system. That kitchen will be your universe. So if you are going to add this system plus surrounding, then you will get universe. Are you getting my point? Anna?
Yes, sir.
Okay. So it's very easy. Moving to the next. Types of system. There are three types of system, which is very important. The first system we are going to discuss is about open system. Then comes your closed system, closed system. Then comes your isolated system. Then comes your isolated system. Now, what is this system? What is the difference between these systems? Open system, closed system, and isolated system. So in open system, we are going to define this type of system on the basis of the according to the system and surrounding. According to the system and surrounding, if you are if the system is exchange, the system which exchange heat and matter with surrounding, heat and matter with surrounding, then that system is called open system. Like if you are going to boil water and there is nothing on the top of the container, so you know that when you are going to boil it, there will be some water in the form of water vapor that will go into the surrounding, that will go into the surrounding, and also heat will be given to the surrounding. So whenever there will be exchange of heat as well as matter with surrounding, that system is known as open system. Now when we are going to talk about closed system, exchange of heat but not matter. Exchange of heat but not matter with the surrounding, then that system is known as closed system. If you are going to boil water and you are going to just close the upper surface, that which was open in this case and you just closed it, then that system is known as closed system, in which there will be interaction between surrounding and system in the form of heat or energy. Now come to this isolated system. What is isolated system? So basically neither heat nor matter exchange with surrounding. Neither heat nor matter exchange with surrounding. And that is your isolated system. That is your isolated system. And you can take an example of thermoflask, in which we keep boiled water, hot water, and it remains hot for a long time. So we basically, it is not ideal isolated system, but we consider it isolated system because it keep the water hot for a long duration of time. So this type of system is known as isolated system. Is that clear?
Yes.
Okay. One more thing is that in isolated system, the boundary we were talking about, let's say, I'm just going to take an example. Let's say this is your container. And if this container is opened on the top, if this container is opened, this shows that it is opened, then it is open system. Then it is open system. Okay. Now let's see. There is nothing on the top of the surface of the container. That is your open system. Now the next is, see, this is close or from all the side close, and this you can see this is your system. This is your system. In the same way, this is also your system. This is also your system. But the boundary, this is your boundary, because as you can see, this is your system. Just after the system there will be surrounding. So this is called boundary. This is also your boundary of the open system. So boundary of closed system is made up of diathermic wall. This is also known as diathermic boundary or diathermic wall. What does this wall do? Basically, this wall has ability to exchange heat, but it cannot exchange, or it cannot exchange basically matter. Basically, what I want to say is that from this boundary, only heat can be transferred to the system, to the surrounding, but matter cannot be transferred. So there can be a question, which type of wall is in closed system? That is your diathermic wall. But if you have isolated system, that is closed from all the side, like closed system, but in here the boundary is made up of adiabatic wall, and this adiabatic wall ensures that there will be no exchange of heat. If there will be no exchange of heat, then there cannot be exchange of matter as well. And this type of boundary basically does not allow the system to exchange heat or matter through this boundary with surrounding. So this is your isolated system. Is that clear? Please do write it. वालेकुम अस्सलाम। हाँ, क्लास ले रहा हूँ मैं, आगे सो गया था। कहाँ है हम? नहीं नहीं, आजमगढ़ नहीं होते हुए जाते। वहां से नहीं है, लेकिन मेरे ख्याल से वहां से मिल जाएगा 37। नहीं, वहां जाके ही पता करना पड़ेगा। What is this? Am I audible? My system just hanged.
So can you explain what are we doing today?
Am I audible?
Yes, sir.
Actually, the system is hanged. Just wait for a minute. It will be working soon. Oh shit, man. Oh yes, this one. So there's a shared screen. Host disabled. Okay. Okay. Arpit, did you ask what I'm teaching?
Yes, sir. I was asking that.
Okay, just wait a minute. Basically, we started this chapter. What it is? This is your thermodynamics. Let me be the host, and then I'll share who is the host. Let me view. Uh, some beta alpha theorem. Okay, everyone. So I was saying that Arpit, basically we were studying thermodynamics, and as you can see, we just started the thermodynamics. What is thermodynamics? Thermodynamics is basically uh, flow of heat in chemical or physical process. That is your That is your that we study in thermodynamics. Now we will go. We are going to see some important terms related to thermodynamics: system, surrounding, and universe. So, what is system? System is basically in which you are carrying the reaction or the process. That is your system. Just after the system, whatever is there, that is your surrounding. Let's say this is your container. So this container is your system. And after this boundary, this is your surrounding. And if you are going to add both system plus surrounding, that will give you universe. Is that clear, Alpit?
Yes, sir.
Now see, types of system. There are three types of system: open system, closed system, isolated system. So in open system, this type of system is based upon interaction between system and surrounding. So if this is an open system, that means there will be exchange of heat as well as matter between system and surrounding, and that type of system is known as open system. And when we are going to talk about closed system, it will allow only to exchange heat, not matter. That type of system is known as closed system. Also, it's very important to note that in closed system, in closed system, the boundary is made up of diathermic wall, which allows only heat to exchange with surrounding, not matter. Now we are going to talk about isolated system. Isolated system does not allow or it can it neither heat nor matter exchange with surrounding. So basically in isolated system, the boundary or the wall of the system is made up of adiabatic wall, we call it, or adiabatic boundary, that does not allow to exchange heat as well as matter with the surrounding. Is that clear,
Sir,
everyone? So this is what I was explaining. Now we are going to see some more important terms in this chapter, and that is there are two types of property in thermodynamics. One is extensive property, and another is intensive property. So basically any property that depends upon size or mass, any thermodynamic property that depends upon size or mass, that is known as extensive property. And any property that is independent of size or mass, that is intensive property. I will take an example. First I'm going to write as mass dependent. Mass dependent, that means indirectly it is saying that size dependent, mass or size dependent. I'm going to write mass or size dependent property. I will take example, you will see. And this is your, see how you are going to remember it. Intensive, it is independent. So extensive will be dependent on what? Mass or size. So mass or size is independent property. Mass or size independent property. Now the most important point here, let's take an example of a class in which you all students are sitting. Okay, and this has a volume 100 meter cube, let's say. Now if you are going to just divide this class, will this affect volume? Yes or no? How you are going to check it whether it is mass or size dependent? If you have a rating is of 100 meter cube, the volume, and if you are going to divide that class in two equal part, you know that this will have a volume 50 meter cube and this will have a volume 50 meter cube. So you can see the size is dependent. This volume depends upon size. That's why this volume is extensive property. This volume is extensive property. Are you getting my point? Yes or no?
Yes, sir.
yes, sir.
Now, let's take an example of this intensive property. Let's say this is the same class in which you all are sitting. here there is AC which cools this, which maintains the temperature of the class at 20 degrees centigrade. Now I just came and just draw a line, or there is a what we call it, parda. I just divided this class into two parts. So can you tell me whether the temperature in both the section will be same or different? What do you think?
Same.
It will be same, Samaira. I just divided this class with a bed sheet. Initially, it is a whole class which has a temperature 20 degrees centigrade. Now, I just divided this class into two parts with a boundary of what we say bed sheet or anything. So for a while, or for few hours, the temperature will be same, 20 degrees centigrade here and 20 degrees centigrade here. Basically, temperature will not change. That means temperature is not depending upon the size. That's why temperature is your intensive property. Are you getting my point? Yes or no? Samaira, Marita,
Yes,
Sania, Anna, Nimra.
yes, sir.
So any property which depends upon mass or size, that is your extensive property, and any property which is independent of mass or size is intensive property. So can any whenever there will be question whether which one of the following is intensive or extensive, there has been question. There are some questions which has been asked. So if I'm going to ask you mole, what do you think about the mole, whether it is extensive or intensive? How you are going to decide it? First, if you know it, you can easily do it. But if you don't know about this, whether it is extensive or intensive, just divide it. If it will change, just divide it. Just consider yourself as mole. I have 8 moles. Now, in a class, 8 moles are there. And if I'm going to divide that class in 2 equal parts, then the moles will be changed. Yes or no? Let's say I have 8 students, 4 here and 4 here. And if I'm going to divide this class, moles will be changed or not? 4 moles on the right hand side, 4 student on the right hand side, 4 student on the left hand side. And initially, if the class was bigger, not divided, the student strength was 8. So basically, this mole is extensive property. Are you getting my point?
Yes, sir.
Yes or no? Okay. Now, there is some important note that you need to take care. First of all, the property, just write this. This is very important. The property which remains unchanged on division. If you are going to divide that property, the system division on division of the system into smaller parts is called intensive. Is intensive basically whenever you are going to divide any system, any property, and you are dividing the system in that property. Okay. So if it will not change, that means it is intensive. Okay. Okay, can anyone tell me whether density is intensive or extensive? If you know the formula of the density or anything, density is equal to mass upon volume, right? Now you can see, going to divide the half, if you are going to divide the volume system, then mass will also be divided into half. Yes or no? Very good. Mass will also be divided by half, because you know that this has a volume 100 meter cube and mass 100 kg, let's say. And if you are going to divide it into equal part, that means now this has a volume 50 meter cube and mass 50 kg. So mass also divided, and you can see again after division you have got the density as m by v, and initially it is also m by v, and that's why density is intensive. That's why density is intensive. Either you can do like this, or either I'm going to give you another trick to know whether it is extensive or intensive. Let me know when you are done with this.
Done, sir.
Okay. Now,
Density is extensive.
intensive. Density is intensive. I have written here. Arpit, any doubt?
Sir, intensive, which is independent of mass and size.
Independent. Yes. Intensive, independent. Now you have to remember it like this.
Okay, sir. Got it.
Okay. Now see, there is another trick to do this, note 2, which is very important, and you can easily connect this with density. The ratio of two extensive property, the ratio of two extensive property is always intensive. Now see what happens here. D is equal to mass upon volume. I'm going to justify this density is intensive property. You can see ratio of two extensive property. As you know, mass is extensive, volume is also extensive, as I explained. So ratio of two extensive property will always be intensive. Always remember that. If I'm going to ask you molarity, you know that number of moles of solute upon volume of solution in liter. If you don't know whether this term or this property is your intensive or extensive, if you know the formula, just write it. Now you know that this number of moles is extensive, volume is also extensive, and ratio of two extensive property is your intensive property. So basically all concentration term that you have studied in solution, as well as mole concept, that is molarity, weight by weight percent, volume by volume percent, mole fraction, normality, ppm, all are intensive property. Because if you will write the formula, you will see in denominator and numerator both are extensive, and the ratio of two extensive property is always intensive. Is that clear?
Sir, molality is also intensive.
Yeah. Molality is intensive because, you know, small m is equal to number of moles of solute upon mass of solvent, whatever is mass is extensive, right? So this is your extensive and number of moles is extensive. Ratio of two extensive property is always intensive. This is what I'm telling you. Okay.
Yes, sir.
Can I change the slide? We have two more classes, right? One or two, I think. Let me know when you are done with this. Also remember that this extensive, I'm going to write, property is additive in nature, and intensive property is not additive. Please do that. See, it's very simple example. 5 kg mass is extensive. 5 kg water, 5 kg anything, 5 kg apple, 5 kg apple, you are going to add it, you will get 10 kg apple. But if you are going to take the density, whether the volume of water is 10 liter or whether the volume of water is 10 million liter, the density of water will be 1 gram per ml. Are you getting my point?
Yes, sir.
That's why intensive property is not additive in nature and extensive property is additive in nature. Now I'm going to give some questions and then I'll rest it up. You just need to tell me, identify the extensive and intensive. You need to identify this. You just don't need to write intensive. You just need to write in bracket whether it is I or whether it is E. Okay. I'm writing all this name as I already explained, but it will be at one page. That will be very beneficial for you. That's why I'm writing all concentration terms. Take your time, think about it, and then you don't need to send all the answer because it will take time. Okay. So I will write it and just match with it. That will be very good. Okay. So please do write in your copy. Alia, finally you came. When did you join? And right now? So everyone check their center where it is.
Yes, sir.
Yes.
Where it is. Where is your center? What is it? Alia, Anna, Arpit, Iram, Marita, Nimrod, Samira, and one more report, Sania. Samira, Riyadh, very good. And Alia, very nice. Lucknow. Arpit, what about you? Sania, Riyadh. Oh, Riyadh. Okay. See, very good, Arpit. Chandigarh. Okay. The most important point regarding your exam is that the question paper in NEET is not that much tough. Very good, Nimra, Hyderabad. But the management, time management and accuracy, that will matter a lot for all of you. So please be careful while solving the question. Concentrate, focused 100%. Paper is for 3 hours 20 minutes. Just let me know when you all are done with this, so that I will start writing the answer. And if you will get any wrong answer from your notes, let me know. Okay, very good, Marita. I'm just want to write density. As I told you, this is your intensive. Temperature is also intensive, but mass is extensive. All the concentration term is intensive. Heat capacity is your extensive. But whenever there is term for a specific it for a particular, it will be intensive. Come to the internal energy. Internal energy depends on basically the number of moles, or uh, that's why it is extensive. Entropy also depends upon the number of moles. Enthalpy, extensive. All these properties, that is very important in this chapter. Internal energy, entropy, enthalpy, gives free energy, because we need to it is important because we need to study deeply about this internal energy, entropy, enthalpy, and gives free energy. Pressure is your intensive property. As you know that pressure is equal to force upon area, right? It is your intensive property. Refractive index is also your intensive property. If you have a glass of 100-meter cube, its refractive index will be same as 10-meter cube of the glass, so it is intensive. Molar volume is intensive, and surface tension is also intensive. So please be aware of this. Is that clear? Arpit, is your all answer correct?
Yes, sir.
Okay. Now the next, which is very important, there are two types of function here, and that is your state function and path function. Path function. You have studied this chapter in physics as well. So see, Any function which depends only on initial and final state. Initial and final state, that is your state function. And in this, it will depend upon initial and final. Depend only on initial and final. And here it depends initial and final state as well as the path. This type of function is known as path function, on which it is covered. So we are going to first talk about the state function. What is a state function? Let's take an example with a graph that is your, just wait a minute. This is your graph. This is your X and Y axis. This is your pressure and this is your volume. And the graph something is look like this. Now there is three path. This is your A point and this is your B point. We need to go from A to B and there is three path. This is your one first path, this is your second path, and this is your third path. And you know that this is your PA and this is your PB. Now if you want to calculate the change in pressure through this path, path 1 I'm going to take path 1. So if I'm going to take path 1, you can see delta P will be equal to PA minus PB. If you are going for path 2, again the change in pressure will be delta P will be equal to PA minus PB. And again, if you are going to choose the path 3, you can see delta P is equal to PA minus PB, right? Yes or no? So you can see the change in pressure in all the path is similar, PA minus PB, PA minus PB, PA minus PB. So basically we can say that if change in, or if delta P is independent of path, if delta P is independent of path, so P is a state function. P is a state function. Are you getting my point? Yes or no? Anything which is anything which if you are going to see the change in that, if it is independent of path, then that function will be your state function. Are you getting my point? Yes or no?
Yes, sir.
So if we are going to take example, we can take pressure, volume, temperature, entropy. Entropy is denoted by S. H, that is enthalpy and gives free energy. And you can either consider delta U or E. This is your internal energy. All these are a state function that does not depend upon path, only initial and final. This is pressure, volume, temperature. S is for entropy. S is for entropy. H is for enthalpy. Delta G is gives free energy. Delta U or U or E is internal energy. So I think it's clear to all of you, right? Let me know when you are done with this.
None, sir.
Done, everyone? Very good. Now see, if we are going for path function, now it's very clear. Path function. Path function, as I already defined it, it depends upon path as well, initial and final, as well as path function. And its example is your heat and work done. Our path function. This is very important example. Please do write it. Then we will go for types of thermodynamic process.
Done, sir.
Very good. Now see, we have some important thermodynamic process we can say, or we can say types of thermodynamic process. Now, what is this? First of all, the type of thermodynamics process is your isothermal process. Isothermal process. As you can see from the name iso, that means same, thermal that comes from heat, and heat comes from temperature. Basically, that means any process in which temperature is constant, then that process is known as isothermal process. Now, one more important point is that if temperature is constant, what does this mean? Delta T, change in temperature, will be 0, yes or no? Arpit, if temperature is constant, so if you are going to calculate the change in temperature will be equal to final temperature minus initial temperature, and that is your same, so it will be 0, or either you can write dt is equal to 0. Samaira, dt is a small change in temperature. Now, the most important point is if I'm gonna write if delta T is equal to 0, then it must be isothermal process. Is this statement true or false? True, false. If dt equals to 0, then it must be isothermal process. This concept is very important and very easy. And students got confused in this, and generally they do mistakes here and got negative marks. Arpit, any answer? Marita? Now see, must be, it's wrong for this delta T. And this is true. Why it is so? So you know that delta T, that only represents T final minus T initial. So if you are carrying a process for 1 hour and delta T equals to 0, it can be mean. It means that initial and final temperature is same, but it is not saying anything about it is not saying anything between initial and final. It may vary, and if temperature vary between initial and final, so it cannot be isothermal. So if delta T equals to 0, that means only final temperature minus initial temperature, okay, which means 0, and between final and initial the temperature may vary or not. So if delta T equals to 0, then it may or may not be isothermal. It not must be isothermal. Are you getting my point? But if dt equals to 0, dt that represents if you are carrying a process for 1 hour, that means every time the value of change in temperature will be 0, and that's why dt, if dt equals to 0, it ensures that the temperature is constant throughout the process, and hence it is isothermal process, and hence it is true. Are you getting my point? Arpit, Samaira, Anna, Alia, Sania?
Yes, sir.
Yes, sir.
Now I'm gonna give some graph So graph is for isothermal. Isothermal, you know, temperature is constant. So do you know Boyle's law? Yes or no? From chapter,
Yes,
from the chapter, which chapter? States of matter, Boyle's law. Boyle's law says that P inversely proportional to V at constant temperature and number of moles. And as I told you, whenever the temperature will be constant, the process is isothermal. So if you are going to plot a graph, there will be two graph here. There will be two graph. For every graph, there will be two graph, and I will explain why it is so. So you know that P versus V, if you are going to plot a graph for Boyle's law, the graph will be like this and this. Now there will be direction. The direction can be from top to bottom and bottom to top. And for this graph, you know, temperature is constant. That's why it is isothermal process. Now this process is known as what we say when volume increases, what we say compression, and another term is expansion. So this process is known as isothermal expansion. This process, this graph is isothermal expansion. Why isothermal? Isothermal, since temperature is constant. Why it is expansion? So you can see the direction of the graph, it is downward, and you can see so the direction of graph from top to bottom, and hence the volume is increasing. Volume is increasing, so expansion is taking place. And in here you can see temperature is constant, that's why it is isothermal. But in here the volume is decreasing. The volume is decreasing, and hence it is isothermal compression. Everyone getting my point? So on the basis of direction, you can easily decide whether it is expansion or compression. Is that clear?
yes, sir.
Okay, can I change the slide? So you need to plot the, I'm gonna give some graph. You need to plot the graph as well as the direction, and tell me the name of that graph. As you know, we are discussing isothermal, so isothermal will be constant, but whether it is expansion or compression, you can easily read from the graph. If volume is increasing, it is expansion. If volume is decreasing, it is compression. So I'm gonna change the slide. I'm gonna give some questions, which is very easy. So the graph is started from here first, and there is another graph for this again, this. Now the graph is in between volume versus temperature, volume versus temperature. This you need to draw the graph for isothermal, and you know in isothermal the temperature is constant, so you can do this. Let me know if you don't know or if you plotted the graph. Are you done with this? See, I just told you to draw a graph for isothermal. You know, isothermal, in isothermal temperature is constant. So you just need to do temperature constant, and it's very easy. You can see that it is like this. Temperature is temperature here is constant. Temperature here is constant. So you can plot like this. Temperature is constant, yes or no? in this process. Now you need to just show the you just need to show the direction. In this, you can see since temperature is constant, it is isothermal, and it is vertically upward going. That means volume is increasing. So this will be isothermal expansion, and this volume is decreasing. Temperature is constant. That's why it is isothermal, and here it is isothermal compression. Is that clear?
Yes, sir.
Is that clear, everyone? Can I change the slide? Okay.
Yes.
Okay. Now the next process is your isochoric process. What is isochoric process? Isochoric process, in this, volume is constant. If volume is constant, that means delta V will be equal to 0 and dV equals to 0 as well. dV is also equals to 0. But one more important again, if delta V equals to 0, that does not ensure you 100% that it is isochoric. But if dV is equal to 0, that ensures you that it is 100% isochoric process. So be careful about this. Now again, you are going to plot the graph, nothing more than this. You are going to plot a graph between these two. And the graph is in between P versus T, P versus T. Again, this graph will be solved if you know states of matter. And the states of matter in this, this is your Galois-Sachs law. Galois-Sachs law. And in Galois-Sachs law, it says that pressure directly proportional to temperature. Pressure directly proportional to temperature at constant volume and number of moles. You know, whenever volume will be whenever volume will be constant, that means it is isochoric process. So since pressure is directly proportional to temperature and volume is constant, that ensures you that it is isochoric process, and P is directly proportional to temperature, so the graph will be a straight line. Now you can know, you know that the graph will be like this. Now, whether it is expansion or compression, how we are going to decide? Since volume is constant, volume is not changing, that means basically there will be no expansion and no compression. So when there will be no expansion or compression, we are going to deal it with cooling or heating. Cooling or heating. So this will have a name since volume is constant. So it is isochoric, and volume is constant. So there will be no expansion and compression. So we are going to give answer in terms of cooling and heating. So you can see in this direction, temperature is increasing. So this is isochoric heating. And in this direction, you can see temperature is decreasing. So this will have a name, isochoric cooling. Is that clear, everyone?
Yes, sir.
Okay, please do write it again. I'm going to give you again a graph. Now this is your graph, and the graph is in between volume versus temperature, volume versus temperature. I'll be back in a minute. Please do this. Everyone done with this? Since volume is constant, you know the graph will be like this, horizontal, like this. Volume is constant. Now you can see like this. Since volume is constant, it is isochoric, and temperature is increasing, so it will be isochoric heating. And this will be isochoric. Temperature is decreasing, so it will be cooling. Isn't it easy? Now another graph I'm going to give you here. And this is graph between P versus V. You need to draw for isochoric. Everyone done with this? Yes or no? It's so easy. Volume constant, this and this. Now see, can anyone tell me whether it is cooling or heating? Samira, Sania, Marita.
Cooling.
Cooling. Arpit. So since volume is constant, so it will be isochoric. Now, if you can see, volume is constant, so we cannot go for expansion and compression. So in terms of heating and cooling, temperature is not directly given, but we know that pressure is directly proportional to temperature. And since pressure is decreasing, temperature will also decrease, and hence, very good Samara, it will be cooling. And here you can see isochoric, and it will be heating. So it's very, very easy, right? The next process is your isobaric process. And from the name, you can easily remember this. Bar is the unit of pressure. So here, pressure is constant. The pressure is constant. And if pressure is constant, that means delta P will be equal to 0. And again, dP is also equals to 0. dP is also equals to 0. Again, the graph is going to start. Please do it on your own. This is between P versus V, and this is also between P versus V. There is another graph that is here. V versus T. Do you know about Charles' law?
Yes, sir.
Very good. Charles' law says that volume directly proportional to temperature at pressure and number of moles constant. Now, whenever pressure is constant, that means it is isobaric process, and the graph will start from this directly proportional, directly proportional. So it will be like this and this. So it is isobaric. You can see the direction is downward. That means volume decreasing. So isobaric compression. And here, if you are going to see, it will be isobaric expansion. You can see the pressure is constant for isobaric. It will be like this, in this, and this. Here, volume is increasing in the first case. So this is your isobaric expansion. And this is your isobaric compression. Is that clear, everyone?
Yes.
Just to write it. Let me know when you are done with this.
Done, sir.
Very good. Now see, adiabatic process. In adiabatic process, as I told you about adiabatic wall. So adiabatic wall does not allow even heat energy to pass through this. So I'm going to write a point. This process in which there is no exchange of heat between system and surrounding. There is no exchange of heat between system and surrounding. That is called your adiabatic process. And since there is no exchange of heat, so the value of Q will be equal to 0. And also dq, if q is equal to 0, so whether you are going to calculate dq or delta q, it both will be equal to 0. After this, the last process here, cyclic process, and cyclic process is the one you are going to where you are going to start, you are going to end at that point. That is called cyclic process. Are you done with the adiabatic process?
Done, sir.
Okay. Now see, if you are going for adiabatic process, sorry, cyclic process. So I'm going to plot a graph and I'll show you. You will get it. What is the definition? You can easily get it. The graph is like this. This is a graph between pressure versus volume, and the graph, this is the point A, this point is B, and this point is C, and this point is D. What happens here is very simple. First, it start from A, go to B, B to C, C to D, and then D to A, then D to A. This type of process, the process in which it starts from A and end at A, that process is known as cyclic process. Okay. Always remember that delta H, delta T, delta G, delta U, delta H is equal to 0 in cyclic process. In cyclic process, basically change in a state function. The state function change in a state function in cyclic process. If you are going to calculate change in a state function in cyclic process, it will always be equal to 0. Is that clear? Please do write it and then let me know.
Done, sir.
Okay. Now the next two process is very important, and that is known as reversible process and irreversible process. I'm going to explain this instead of writing the definition. See, there is a container, and again, there is a container. Now, the most important point here is that this container has a piston. And with the help of this piston, you can easily increase or decrease the volume by applying pressure, by increasing or decreasing pressure. In the same way, there is irreversible process in which there is a piston with the help of which, if you are going to push it, pressure will increase and volume will decrease, and if you are going to pull it, pressure will decrease and volume will increase. Now see, if you have sand here, a bag of sand that is of 50 kg. So you know, infinite particles of sand particles will be there, right? Yes or no? If it is a 50 kg, 100 kg, 10 kg, you can take sand, that is wraith, and you are going to just pick one particle of the sand and you are going to put it here. Will it affect the piston? If you are just going to pick a sand particle and put it on the piston, will it affect? Yes or no?
No.
No. Simple. It will not affect. So this reversible process is very, very slow. What we call it in this, infinitesimally. Very, very slow. If you are just going to pick one sand particle, put it for a long time, it carries in infinite state. In a reversible process takes to complete in infinite state, and you will not able to see that when it is going to change, because the process that is carrying is very, very slow. Whereas in irreversible process, you are just going to put all the bag here directly, 10 kg sand here. So what will happen? This piston will directly come here and you will look at it. You can easily find it that it just moves downward, increases pressure and decreases volume. So first of all, carries in finite step, and fast process. It is fast process. This is your very, very slow process. This is your fast process. Also, equilibrium at initial and final only. Initial and final. Let's say before sending the bag of the sand, it was here, that is at rest. That means it is at equilibrium. Now, when you are going to put the bag on that, it will directly come here, and now it is stable here. So it maintains irreversible process, maintains equilibrium at initial and final state or final position. But in a reversible process, what will happen? If you are going to pick 1,000 or lakhs of particles of the sand, what will happen when it will move towards the bottom, or when it will start pressurizing the piston? You will not able to see, basically you will not able to find out when it moves this much downward, because it is very, very slow. Are you getting my point?
Yes, sir.
So basically, this is the difference between reversible and irreversible process. Also, I talked about equilibrium at initial and final in irreversible process, and here equilibrium at every stage. At every stage. That's why we are not able to find when it moves to downward. Okay, is that clear?
Yes, sir.
Okay, now I'm going to directly write the formula for work done in reversible and irreversible process. First of all, for irreversible process, the formula is minus P external into delta V. What is delta V? Delta V is change in volume, or you can write minus P external into V final minus V initial. Now, if you are going to calculate the work done for this reversible process, it is minus 2.303 nRT log V2 upon V1, or you can write in terms of pressure as well, minus 2.303 nRT log P1 by P2, log P1 by P2, and it's very, very important formula. Now, how you are going to recognize whether which one is reversible and irreversible. So always remember that whenever in questions it has been written external pressure constant, whenever the external pressure will be constant, then that process is irreversible process. Irreversible process. It will be directly written in the question that the pressure, external pressure is constant. That means it is irreversible process, and you are going to apply this formula for to calculate work done. And if it is reversible, then you are going to apply this formula according if it is volume given this, and if pressure given this. V2 is final volume, V1 is initial volume. So I think it's clear to both of all of you, right?
Yes, sir.
Oh, very good, very good. Are you done with that, everyone? Arpit, are you there? Oh, is there? Sami, Akbar, Alia, and Marita. Okay, can I change the slide?
Yes, sir.
Okay, now I'm going to give you a question on this. This is your question. It's NEET Odisha 2019. Please do it. Alia, Emma, Ira. Wrong answer it is, Marita. Should I explain? See, I'm going to explain. An ideal gas expands isothermally from 10 raised to the power minus 3 meter cube to 10 raised to the power minus 2 meter cube at 300 Kelvin against a constant external pressure, constant pressure. That means it is irreversible process, and for irreversible process, we have formula this P external into delta V or dV you can write. You can see minus is there. P external is your what? 10 raised to the power 5 Newton per meter square. And this is your final, that is 10 raised to the power minus 2 minus 10 raised to the power minus 3. Now you just need to solve it, and you can easily do this. I think 10 raised to the power 5, and here what we can take common from this. How can you solve it? I'm just gonna, oh, wait a minute. You can do this as well, 0.01 minus 0.001, and then you can easily solve it. Then you will be getting minus 900 joule, not kilojoule. Is that clear, uh, Marita?
Yes, sir.
Okay, so this is it for today. In the next class, we are going to cover internal energy, enthalpy, and entropy, as well as Gibbs free energy. So please do read about this. And after that, we will talk about the thermochemistry, which looks tough but very easy.